Let's talk about something a little different now. Let's talk about Randy the Continental chassis. This one is a little bit different than any of the other projects we're going to be involved in because I don't have the whole set. This is the chassis for a Continental, which is a 21-inch set that uses the same chassis as the 17-inch sets. I believe it was the last model they introduced, which is kind of a shame because it seems like they were slowly working out all the kinks and improving the design. So all the other 21-inch sets are series strung, no power transformer. I don't know why they didn't use this chassis in all the Predictas, because it works rather well, and it's got a power transformer, which is generally a good thing. Why? Well, for one, you don't have a hot chassis, so it reduces it improves the safety of the set. It means you can wire all the tube filaments in parallel, so you don't have to worry about current surges on startups. You don't need to have a thermistor. You don't have to deal with the issue where the tube filaments don't add up to the same as a line voltage, and you have to add in a ballast. Anyways, there's a number of pluses. So that's why one reason why this model is desirable. Also, they changed up the pitcher tube. The earlier pitcher tubes had a bit of a design flaw in that they tended to have a short life. This one, they switched up the pitcher tube to a different one that doesn't have that issue. Alright, so initially when the owner of this contacted me, he doesn't live near me, so we knew he couldn't really realistically get the whole set to me, but he wanted me to work on it. So he took out just the main board and sent it to me. And he undid wires, and he labeled all of them. Well, we got to thinking and decided, well, you just send me the whole chassis. So that's what I have here. The idea being, since it is the same as a 17-inch set, I can use one of my existing sets for the pitcher tube and the speaker and whatever else I don't have here. Okay, and yeah, it really, even though it's a very different looking cabinet and a 21-inch pitcher tube, this is essentially the same 10L43 chassis as we've seen in all the other sets. There are a few minor differences. For example, this has a tone control. So on that control cluster where typically we have 3 pots, this has 4. Now, all the other boards we've done, they all have a stake 4 tone control. Right there. You can read upside down. It's just left unused. But theoretically, you could add a tone control to any of the 17-inch models, if you so desired. Otherwise, I believe this board is identical. As generally speaking is the chassis. One other difference is that this is mounted vertically in the cabinet, and they've attached the chassis and the tuner to this heavy masonite board, which is a little different. It's also not incredibly sturdy. It bends a bit under the weight, especially I noticed around where the tuner is, probably because of the weight of the transformer. Alright, let's switch to talking about condition. The set's a little rough. It's been worked on before. I don't exactly know what they did, because this appears to be all original. Or very, very little has been done to it. Maybe that's a new cap? It's hard to say. I started doing some work, so some of what you see. Oh wait, now it's coming back to me. They did some work in this area. And when he first showed me photos and we looked at this, we thought, oh man, that looks like horrible. What happened there? Well, it turns out that they did a horrible soldering job, as we've seen on some of the others. Either They didn't have the proper soldering tools. So there's some really ugly looking joints here. Looks like they probably lifted a trace and they installed a wire here. And then they coated the whole thing in Gliptol or some type of conformal coating, and then it ran down the board. So we're going to clean all that up. Hopefully it won't be too hard to strip this stuff off. We're going to clean up all these joints. What was the issue exactly? I don't know. Those appear to be the original tube sockets, so I don't think they changed them. Where they have that jumper wire going from here to there, the trace looks okay underneath it. So I'm not sure exactly what problem they were solving. Now that is a ground, and that goes to one of this, I think. Oh no, sorry, that's a filament supply. That's a filament supply wire going down there. Anyway, something happened in that area. We're going to clean it all up. We're going to go all over it. Ooh, see that resistor's cracked. I mean, hey, maybe they weren't able to solve the problem. I'm making assumptions here that whatever they did fixed the problem. Maybe they didn't. I also noticed that some of the caps are cracked. Like that guy. And that one's starting to open up. These are paper caps inside of plastic tubes. The paper fails over time. They get hot when you're running it. They start swelling and the plastic starts cracking. Now, because of some of the condition issues and that this is a rather valuable set, I'm going to go full bore on this and just do everything, including replacing all of the tube sockets. I've already done 2 of them. And a couple of these tubes were stuck in there so firmly. One of them wasn't the original, but one might have been. And those are the ones that have shields. I couldn't get the tubes out without removing the shields, so that's why those shields are off. But it also means I can get at those sockets more readily now to replace them. So we'll do the usual. We'll just blow through this whole board. Same on the chassis. We'll blow through all that. These are all notes about what wires connected where. This looks to be all original too. Now there's one other major cause of concern. The tuner. The tuner has no cover on it. There should be a metal shield over that. Here's a better look at it. I think you can see how much dirt there is inside and fuzzies and whatnot. So that cover's probably been gone for a long time. Not a good thing. You don't want to get dirt inside the tuner. And you need to be really careful when you clean it, because all those little coils there, you can't move them. You can't touch them, or you're going to throw this thing off. So we'll use some compressed air, light brushes, whatnot, and clean it out, and then we need a cover. I mean, I think, have a spare tuner that's compatible with this, so I might just swap it all out. But, you know, these parts are hard to come by, so I'm not crazy about just having to give up my only spare tuner. But we'll see how it goes. Yeah, of course, I could try fashioning one out of some sheet metal if it comes down to it. Now, there was one other thing that happened. It's a little hard to see with it still on this masonite, but we'll take this chassis off eventually. But I think you can maybe see through there. Whoever worked on it before, when they dealt with whatever they did in that corner of the chassis, they didn't take the board out. They cut out a section of the chassis. The chassis does have some holes in it, so you can get at quite actually a fair amount of the board without taking it out. But some areas you just can't, and they chose to hack away and bend and contort the metal to get at whatever they wanted to get at. Now, again, I do have maybe 1 or 2 spare entire chassis, so that is not entirely inconceivable that we could. I'm not suggesting that we toss this entire chassis and use a different one. On the other hand, it would be quite a bit of work to transfer everything to remove everything from another chassis and then transfer all of this stuff onto it. So I think we'll stick with making this one work as best we can. One last thing, let's peek in here. Oh, not too much to see. It looks all right. I've seen worse. There's not much corrosion, so that's one positive. There's one other thing I want to mention before I get back to working on this, and that is good old TV Restorer guy who makes the lovely reproduction networks. Also set me up with this. See, he happens to have restored one of these, and he is meticulous and he is a pro, and he realized that there should be a heat shield down in there somewhere. See, when this is in the set and it's mounted vertically, and I believe, yeah, the tuner's at the top, so this would be the top and this would be the bottom. So imagine this is going like this. Well, what sits right here? The horizontal output tube and the damper tube. Those get pretty hot. So when this is running, the heat is going up and it's roasting the flyback. This is a heat shield. I'm not entirely sure if they had it original or not. I'd have to go back through my notes. I remember when he restored one of these, and I remember him coming up with this. But I can't remember if he saw the remains of an original one. I'm sure it would have been asbestos if there was one, or if he just concluded that it would benefit from having one. Either way, we've got one, and he sent me instructions on how to fold this. It needs to be folded around a bit. I'm not sure exactly if it goes this way or that way, but that hole there with that rubber, that is for this lead to go through. I suppose I'll have to unsolder it to thread the wire through there, but that is not going to be too difficult to do. And that will definitely help out the flyback to last longer. So we've got all of our parts, and we've got our new sockets, and we've got our cup plates, and we've got our heat shield. So there, we are ready to go and proceed with this one. There are a few bits and pieces that are corroded here and there. These will go into an evapor-rust bath as usual. I'm just going to start going through this. I'll pick up when things are much further along. Oh, and of course, why not to just keep things being fun? I believe this needs a new linearity control, but we've got our new design for that. So I think we're all set with everything we need for this set. I've been examining this damaged corner, trying to figure out what the heck is going on, and I think I know now. I haven't had much luck in dissolving this coating, but I was able to melt the solder and wick a lot of it off. They really had glopped it on down here. What I discovered that was for these two octal sockets, virtually every pad has lifted and traces broken. There's a good example right here where the trace is cracked right there. And these are all loose. All these traces have lifted up. Now these sockets do look old, but it doesn't mean that they're not replacements. It might have just been done a while ago. Or maybe they removed the originals to clean them or something. I don't know. They are kind of chipped up where in the middle there, so that they do look like the originals. I also noticed that, well, at least this one is crooked. I didn't do a very good job of remounting it. But the real problem came when they reinstalled them and soldered them, or maybe while they were removing them, they damaged every single trace and pad going to those tube socket pins. Here's a good example. Trace is cracked, pad is loose. Loose pad, loose pad, loose pad, broken trace. Some of the broken traces they fixed by just glopping out a whole bunch of solder. Some, like here, they put a bare piece of bus wire to bridge the break. As was that wire that I saw snaking around. It was going from up here down to here, and I couldn't figure out why, because the traces looked fine. And then I realized when I cleaned out some of the solder, it's actually cracked right here. So, somebody did a really horrible job, a real disservice to this board, They either used way too much wattage or too much force or kept the iron on there for too long. And inadequate wattage can be just as bad as too much wattage, because then you're leaving the iron on there for a prolonged period of time trying to melt the solder, which can cause the trace to lift. Also, when you're putting a new socket in, like these ones I've been replacing, make sure all the holes are really cleared out well. Otherwise, when you're putting in the new part, you can catch the edge of the trace and just bust it right off the board. So what am I going to do? Well, I'm going to remove all the excess solder, clean up all the pads, examine the damage, do a neater job of repairing it, and move on from there. I tried isopropyl alcohol on this. I'll try lacquer thinner next. If that doesn't work, then I'll just concede that it's going to stay. But it melts very easily with a soldering iron. So as soon as I touch any of these areas, it just goes away. Maybe not the best stuff to breathe, but I've got a fan going with some good ventilation. I finished restuffing the main board, including replacing all the tube sockets, except for the octals. They look to be in pretty good shape, so I left them alone. And I did rework that corner of the board. I cleaned as much of that old goo off as I could. I identified all the broken foil traces, reseated the sockets, and went over all the breaks, bridged them with bus wire or insulated wire as needed. I think we're good to go with that. So, moving on to the main chassis, I unmounted it from the board, and you can see where they cut out a chunk of it. So then there should be a piece of metal in here, and they rather crudely snipped it out. I say crudely because there's really sharp metal bits kind of bent and twisted and contorted around. Anyways, with that opened up, I took the IF shield off, took the IF board out. We're going to work on that. We're going to clean that up in some CLR. Same with the high voltage box. And once that stuff's out of the way, I find it much easier to work down in here. So even if I wasn't going to restuff this or do anything with it, I like taking it out, because there's a terminal strip down here we want to work on. We're going to replace these two diodes and put in some new caps, and we're going to replace that cap. And hidden, tucked away back there, is a line filter cap that's virtually impossible to get at unless you take this high voltage box off, at which point we can also examine the flyback tuner. Not surprisingly, it was really hard to turn with it being all exposed and filthy. Between some electrical parts degreaser and some new grease and some clock oil applied with a needle oiler, I was able to get it working pretty well, including the fine tuning, which was really stiff. It's just kind of stiff, which you actually want, because you want there to be some resistance when you're rotating that fine tuning knob. After all, once you've adjusted it properly, it should stay in place. Now, as to whether or not it works, well, we shall see. We shall see. Oh, and I sprayed some deoxit down in on all of the switch contacts. So next up, I'm going to tackle all this stuff. Once after removing the high voltage box, I put it in some CLR to clean it up, and notice that one side of it is a bit discolored and there's a little blob down there. Well, that side normally goes here, and this chassis is mounted vertically. That is from wax that has dripped off of the flyback. Notice there's a section missing here. Well, we're going to take care of that with some Super Corona Dope. I give you a little brush there. We're just going to brush some on. This is sort of like lacquer. It sets up really fast, and it has really good dielectric strength. It's good for many thousands of volts, so just brush some of that on, and we'll be good to go with that. I'll put a little bit around here to reinforce this wire that goes to the high voltage rectifier tube. And while that was off, I also replaced the across the line cap. While doing so, I noted that on this AC interlock, this is where the AC plug comes into the set, one of the pins is a little loose. The phenolic is kind of crumbled around it, and it's been pushed in a little bit. I'd like to replace that whole board. I've got one or two parts chassis. I'll see if I can find one that's in better shape. I'll have to drill out the rivets and replace them with some machine screws. But considering that's where the AC line comes in, I think I should make it as safe as I can. With that cover out of the way, I also went in and rebuilt the voltage doubler B+ power supply area down here. And noticed a wire that goes to one of the flyback windings and snakes around and goes over to the board is the insulation is compromised. It got very brittle over time, and it's failing. This has a bit of a high voltage pulse on it, I believe. That's why it's different from the other wires. So I want to replace that with some wire that's rated for higher voltages. I just placed an order with Mauser because I needed some other stuff, and I went ahead and ordered two 50-foot spools of instrument lead wire. It's good for 5,000 volts. It's very similar to this stuff, and that's why they sell it, so you can make your own test leads if you like. Well, it also has good insulation properties, so that's what I'll replace that with when it arrives in a couple days. I've also been scratching my head a little bit over a couple things till I realize that's because this is a late production run. It's a bit different from the other chassis we've been looking at. One easy way to tell that is if it has this little board over here with a resistor added to it. That was done in run 5. 3-lug wiring panel was added, a 6.8K resistor, and so on. I also noticed that there's a capacitor missing. To facilitate production, the 0.1 microfarad 200 volt IFB plus decoupling cap was removed. It normally sits on this terminal strip here. One end goes to ground, the other end simply goes to a wire that goes over to the IF board into this lug. And before I realized that, I went ahead and installed the cap over here, which is what I typically do, because modern caps are so much smaller now, there's no reason to have it on a separate terminal strip. You can just mount it right here. But now I'm torn. I'm inclined to leave it. They say they removed it to facilitate production, which to me means to save time and money, not to improve the circuit functionality. It's simply a filter cap on the IFB plus supply, so a little extra filtering doesn't hurt anybody, so I'm inclined to just leave it there. So I think we are at the point now where we can start doing some reassembly. So next up I'll reinstall the IF board, and I do have a power resistor I need to replace over here, and 3 electrolytics are going to get installed on this terminal strip. I want to hold off on doing major work around here though until I get the replacement wire for that guy. And there's just one other thing that I'm not at all certain about, is what the heck are these for? On the other chassis I have, that's where the local distance switch is mounted. There's a little piece of metal here with a slide switch. And on some of the debutantes, they removed that switch because they were used in hotel, motel with, they were wired into a distributed coax system, so there's no reason to have a local distance switch. But this has standoffs with machine screws in them, and they're kind of bent and twisted and don't fit that well. I got to consult with some other owners of the Continental, because this doesn't look right to me. I don't know if these are original or not, or they got bent over time, or what the heck they're supposed to do. They don't seem to be really doing anything. And these are cut off. What I think maybe is the local distance switch was relocated in this model, and that's what these 2 wires go to. And maybe something gets mounted on this. I'm not sure. I'm not sure. Otherwise, I have a pretty good handle on the rest of this. I know it looks like a bit of a mess right now, but it makes sense to me. One other thing that's a little bit different too is the power, which I believe this goes to the power switch is over here, and the wires are no longer, oh, it's shorted. Huh. Okay, I see. So this may be the first set we've encountered where the power switch has failed. I'm not going to take their word for it. I'll remove that short and work the switch, see if I can get it going. You can see there's 3 tabs that hold it on. I can pry those off and get the switch out and try cleaning it out and reviving it. It can be done. It's not trivial. Basically, the contacts get dirty or the grease hardens and the action doesn't work right anymore. But let's see what we can do. Worst case scenario, what a lot of people have done in this situation is you short this out so the set's always on and you connect it up to a power switch, or sorry, a power strip that has and you control the set being on and off with the switch on the power strip. It's a lot preferable to drilling a hole in the cabinet and installing a toggle switch in the side, which I've also seen, and we aren't even going to think about doing that. Not so fast. I was going through the control harnesses here and realized, oh, we do have the local distance switch. But what is up with this? It would normally just mount here. I don't get what's going on with this. You can tell from the marks on the metal that, yeah, the screws went through that. I mean, what, did they mount it back here to get it so it wasn't against the I don't know. And I think it hooked up to this. Doesn't quite look like the other examples I've seen.